Hi, everyone, and welcome to our What's New in SAP HANA Cloud for Q2 2026 webinar. My name is Andrea, and I am part of the SAP HANA Cloud Product Management team. And today's webinar will definitely not be able to cover the full scope of all the innovations that we have for the latest release, but we will give you an overview of the most important innovations that have been delivered with the release. So if you want to get a more comprehensive overview, don't forget to check, as always, our upcoming What's New blog post, as well as the technical documentation that contains all the details of all the innovations that have been delivered. And as always, my colleagues from the product management team are in this call with me, and they will give you a deep dive into the topics. They will also be happy to answer your questions in the Q&A. So don't forget to post them through the Q&A tool. Let's jump to the agenda. So first, I will be giving you a general update on our innovations, and then Tesuk will be speaking about the SDA ABAP adapter replication and automated plant management. Then Hansika will take over with the innovation in SAP HANA Cloud Security, and Bojana will be speaking about the innovations in SAP HANA Cloud Data Lake. Afterwards, Shabana will be giving a knowledge graph engine update, and Christoph will be speaking about the database and machine learning and AIs and AI core integration. And last but not least, Raj will be giving an update on the multi-region disaster recovery capabilities. So let's jump right into the general update. So first, we have this a look at a major scale-up capability for SAP HANA Cloud, the introduction of large instance sizes on Amazon Web Services. With this release, SAP HANA Cloud now supports instance sizes of 16 terabytes and 24 terabytes of memory on Amazon Web Service. This is an important step for a customer running very large business-critical workloads that require substantial in-memory processing power. So until now, customers with extremely demanding workloads could face a practical ceiling at 12 terabytes. With these new larger instance sizes, SAP HANA Cloud can scale further vertically, allowing more data and processing to be handled within a single instance. So this helps customers address high capacity scenarios without having to introduce architectural complexity or split workloads unnecessarily. The way this works is slightly different from standard instance provisioning. These large instances run on dedicated physical hardware, which is pre-reserved exclusively for the customer's sub-account. Because of that, the capacity is reserved under a 3-year commitment in a selected availability zone. It is also important to note that these instances cannot be provisioned directly from SAP HANA Cloud Central in the same way as regular instance sizes. Instead, customers are guided through SAP HANA Cloud Central to raise an SAP support ticket and request the required capacity. Once the request is approved, SAP procures and allocates the dedicated hardware. After that, the customer can provision the SAP HANA Cloud instance against the reserved capacity. The key takeaway is that this removes the previous 12 terabyte ceiling and enables SAP HANA Cloud to support some of the most demanding workloads with 16 terabyte and 24 terabyte options. And at the same time, customers should plan ahead. Metering starts from the point of reservation, regardless of the instance state, and availability is limited to selected Amazon Web Services regions. Since provisioning depends on infrastructure allocation and may involve lead times, early management with SAP is strongly recommended. Next, we have, with the Q2 2026 release, SAP HANA Cloud Database introduces post-quantum cryptography for TLS connections, providing quantum-resistant protection for all data in transit between clients and SAP HANA Cloud databases. Post-quantum cryptography addresses the harvest now, decrypt later threat, where adversaries capture encrypted traffic today with the intent of decrypting it once quantum computers become capable. But enable PQC now, SAP HANA Cloud ensures that data encrypted today remains protected against future quantum attacks. Key capabilities include the hybrid post-quantum key exchange, A transparent ML key establishment negotiated during TLS 1.3 handshakes, combining classical and quantum resistant algorithms. Enabled by default for SAP HANA Cloud databases with no customer configuration required. There is full backward compatibility, so the clients with PQC support automatically negotiate a quantum resistant hybrid exchange. Clients without it support safely fall back to classical key exchange with zero disruption to existing applications. We also have built-in observability. So the new SSL key exchange and SSL signature columns in M connections and in M outbound network EO systems views, enabling administrations to verify PQC adoption per connection and identify clients that need upgrading. This feature is aligned with NIST post-quantum standards ahead of anticipated regulatory mandates and requires no customer action to activate. Typical use cases include verifying quantum safe connection status across the landscape and meeting compliance requirements for post-quantum readiness. Next, let me talk about the new innovation of the Performance Class Advisor, which automatically analyzes your SAP HANA Cloud instance compute and memory usage and tells you whether you need to upsize based on actual usage data, not guesswork. Here's how it works. You pick a look-back window, 2, 4, or 6 weeks. The best reflects your typical workload. The advisor then checks whether your CPU or memory usage has exceeded 80% during that window. If either one has, a recommendation is triggered. And the advisor finds the optimal upsize spec, roughly 20% more capacity. Snap to the nearest valid instance configuration. And in this initial release, recommendations are limited to upsizing only. Once you switch it on, it runs automatically every Sunday at midnight UTC. No manual triggers are required, no recurring setup, and switch it up once and it works for you right from there. The value then comes down to 3 things. First, right sizing guidance grounded in your actual workload history, not a best guess. Second, proactive resource management. You see the pressure building before it becomes a business continuity problem, so you have time to act rather than react. And third, automated insights delivered weekly with zero manual effort. One-time setup and continuous visibility. And with that, I would like to hand it over to Tesuk.
Thank you, Andrea. So today I would like to present 2 features. I think those are very important features for the SAP HANA Cloud. The first one is supporting the replication within the SDA ABAP adapter. And the second feature is now we're starting to automate the plan management as part of the SQL Plan Advisor. So first, let me start off with the ABAP adapter replication. So previously, we supported SDA ABAP adapter connecting to on-prem or S/4HANA public or ABAP environment from HANA Cloud. But it was supporting federated queries when we initially released the ABAP adapter. Now with the QRCO2 release, now we're supporting the replication of the ABAP CDS view entities from an ABAP platform 2025 or higher to replicate the CDS entities from these environments into the HANA Cloud. They are CDC based, so the delta or the change data are replicated from the source system to the cloud environment. Previously, there was another option to replicate data from a ABAP environment using RTR, which is actually replicating the underlying HANA database as the source system to replicate data to HANA Cloud based on log-based transactions to be replicated. But it was not fully compliant with S4 as it was referencing data that is underneath the application side. And with this new enhancement, we're now fully compliant with the application side, whereas we're replicating based on the application. So the connection from the HANA Cloud to the ABAP environment is a connection to the application itself. Since we're replicating the data from the on-prem into the HANA Cloud, the key benefit is that um, there's a lower latency in accessing the data, and also it is fully ABAP SQL compliant with the ABAP and also the ABAP semantics as well. Also, the key difference is over RTR is that we do allow filtering based on some conditions and also subset of data using selecting a needed column only to be replicated in HANA Cloud. So to check on how it works, first, it is very similar to replicating using the existing SDI or the existing SDA replications, where we create the virtual table, create the target table, and then create a remote subscription. And when we're creating the remote subscription, this is where we can put in filtering or selecting the subset of the columns to be replicated to the target system. Then we queue to do the initial loading. And then for the delta load, there's two options where we can schedule based on intervals that we can set, or by default, integrated or interfaced every hour. The second option is to do it manually by sending this auto remote subscription delta load command every time you want to manually get the change data from the source system. That's it for the ABAP replication. And let me go to the second feature, which is the automated plan management. Previously, we had released the SQL Plan Advisor, where it detects any performance degradations in the system compared to the historical execution of the same statement. And comparing the statistics with the current execution and the previous execution, the system can automatically detect if the performance of the statement have been degraded. But previously, using the SQL Plan Advisor, the administrator had to manually start the testing process to validate if one of the previous plan was an optimal plan, and then be applied to be swapped out with the current plan with the more optimal plan. We've actually enabled this as part of the QRC01 2026 version. But we've been monitoring, the engineering team have been monitoring on a daily basis that it's not introducing regressions into the system. And we have validated that it is working as expected. And based on our telemetry data that we have observed for the last 3 months, is that there had been a few cases where a performance had been degraded in some of the systems, and we validated that 155 plans were degraded and actually recovered using one of the older plans, and some of the improvements shown like a 20% improvement uh, when we tested and validated and applied the more optimal plan. Currently, there are some features that is still out of scope. For parameterized queries, we first check if this can be covered with the plan variant. Plan variant means multiple plans for the same statement. For this case, we think plan variant would be more optimal solution, but since it needs to test 50 times, that we have not covered to be automated for such a case and rely on a manual testing to be started for such cases. But if it's not part of the plan variant, then we do utilize the uh, previous historical plan statistics to check if we can further optimize based on the historical. Also, what we're planning is to increase the coverage, uh, like supporting the calculation scenarios or calculation views, MDS queries, and also the SQL script inner statements, which has some limitations due to table variables converting to temp tables, meaning that every time the procedure gets recompiled, the new temp table gets created. So we lose the continuity of the historical statistics. And so those are the things that we would like to improve later this year. And that's it from my side. Thank you.
Thank you, Taesuk. So hi, everyone. I'm Hansika. I am the product manager for security and compliance. Today, we're covering two closely related capabilities that together deliver compliance for sensitive data access in SAP HANA Cloud. The first is column level security for SQL views, and the second, access logging. Together, these form two pillars of our data protection story, preventing unauthorized access and logging all access for audit purposes. So let me frame the context. So regulations like GDPR and the EU AI Act, among others, require first that you prevent unauthorized access to a personal data, and second, that you can demonstrate accountability and an auditable record of who accessed what. Direct SQL access to HANA databases containing sensitive data requires both enforcement and audit trails to meet these compliance requirements. That's why we are delivering two complementary capabilities. Column level security, which is the prevention side. It ensures unauthorized users cannot see logging, cannot see sensitive columns by returning null values. And access logging, this is the detection side. It logs who accessed which sensitive columns, when, and on which table, without ever logging the actual data values. Together, these capabilities enable compliant direct SQL access to sensitive data in SAP HANA Cloud. Let me walk through how column level security works. This is the enforcement side. Columns on SQL views are tagged with DPP classification, identifying them as containing sensitive personal data. The authorization model then maps which users or roles are permitted to access which tagged columns. At query time, the engine evaluates the authorization dynamically. It is not tied to the current database user and can rely on any information in the session content or other tables. If the user is authorized, actual values are returned. If they're not authorized, null is returned. The key design choice here is that columns are masked with null, not emitted from the result set. This means your query always returns the same column structure regardless of who runs it. Downstream dashboards, pipelines, and applications remain stable, and unauthorized users just see null where sensitive data would have been. So no query writing is required by the user. No multiple view copies are needed. The evaluation is dynamic, and it happens at query time, not at configuration time. So when authorization changes are made, they take effect immediately, enabling broad SQL access while ensuring sensitive personal data is only visible to authorized folks. So there's no operational burden of maintaining duplicate views per user group. Other object types can participate by being wrapped as SQL views. Now through to how access logging works. The feature is activated directly in your table definition using the audit read syntax in your create table or alter table statement. Once the column is marked, read access is automatically reported through the predefined SAP column access audit policy. You don't need to create custom policies. The system handles it based on the column marking. Both direct and indirect access is reported. If a user queries the base table, that's logged. But if they access that column through a view or during procedure execution, it's still reported. This hierarchy-aware behavior is critical for compliance. There are no blind spots from indirect access paths. When an entry is generated, it includes the schema name in the schema name field, the table name in the object name field, and the list of access columns in the value field, along with other fields that are generally logged with audit events. Crucially, the actual data, values, and SQL statements are never logged. This is privacy by design. The audit trail provides accountability without creating a secondary repository of sensitive data. The benefit to you can demonstrate to auditors exactly who accessed sensitive columns and when, and there's no custom audit policy creation needed. It's system managed. It's activated via standard DDL with minimal operational effort, and it's hierarchy aware, so it covers access regardless of the path taken. A few limitations to note: only column store tables are supported in this release. Row store tables and virtual tables are not supported, and access through cached views might only be reported during the initial caching, not for subsequent cached access. So let me bring this all together with the combined value of both capabilities. For compliance and audit, you can now improve compliance to regulatory accountability requirements. You can prevent unauthorized access through column-level security and track all access through access logging. You have concrete, queryable evidence for auditor inquiries, and you avoid regulatory penalties and audit findings. For data consumers and operations, direct SQL access to sensitive data is now possible compliantly. Query structure remains stable thanks to null masking rather than column omission. There's no need for duplicate views or application layer workarounds, and the operational overhead is minimal. DDL-based activation for logging, a system-managed audit policy, and dynamic authorization evaluation for security. For trust and adoption, users see only data they are authorized to access. Data owners have auditable evidence of all access events, and this supports broader data consumption and analytics adoption across the organization. Together, these two capabilities deliver compliant direct SQL access to sensitive data in SAP HANA Cloud. Thank you, and I will be handing it over to Bojana.
Thanks, Hansika. Today, I will be talking about the use cases for Data Lake Relational Engine, and I will talk about our new Q2 feature, Think Loan Decoupling. We have divided the use cases for Data Lake Relational Engine into three categories. The first one is migrations from on-premise IQ to Data Lake Relational Engine, where customers can benefit from enhanced scalability, flexibility, reduced maintenance effort, lower TCOs, automatic backups, point-and-click restore, to name just a few. The second category is migrations from on-premise IQ to Data Lake Relational Engine in BW for HANA data tiering optimization, or DTO, where on-premise IQ is used as DTO storage layer. Besides the benefits I've just mentioned for moving from on-premise to the cloud, I would like to emphasize that migrating to Data Lake Relational Engine offers supports larger data volumes, which are not supported by on-premise IQ, and significantly lower TCOs. Third category is data tiering within SAP HANA Cloud. In the cases where customers have fully utilized the provisioned HANA capacity, and they can offload their workloads and data to Data Lake Relational Engine, a petabyte scale data storage. Data Lake Relational Engine is capable of handling complex analytical workloads by our query processing engine, and frequent workloads that on-demand computing cannot handle in terms of TCO gains, with good performance and TCO benefits. We have noticed that in the last year, increasing number of native storage extension, or NSE, customers with data volumes larger than 1 terabyte. And this increased data volume drives Data Lake Relational Engine adoption. Now on to our Q2 feature, which is thin clone decoupling. Thin clone decoupling builds on top of thin clones, a feature that we have released last year. Thin clone decoupling promotes a thin clone to a standalone data lake relational engine instance. And this instance, once promoted, behaves as any other regular data lake relational engine instance. It has a full copy of the entire database with fully independent storage. Just to remind you about thin clone, this feature actually is able to create and deploy thin clones from petabyte scale databases in just a few minutes, and this is useful for test and development purposes. Thin clones are created from a selected parent backup, and they share the database storage with the parent instance. Separate page list is maintained so that any page updates that are happening for data changes through the thin clone are maintained by the thin clone itself. With the thin clone decoupling, we are actually promoting these test and development databases to production grade instances. During the decoupling process, the thin clone maintains read access to its parent instance, and it is still available to service requests. The decoupling process can be cancelled at any time. The thin clone cannot be stopped before cancelling the decoupling process first. Once decoupling completes, the decoupled instance behaves as I already mentioned, any other regular data lake relational engine instance with all the features available. And this decoupled instance has backups enabled. Because of this, other thin clones can be created from the decoupled instance whenever needed. This is how it looks like in HANA Cloud Central. Here we have our data lake relational engine instance, and we're going to create a thin clone out of it. So this will be our parent instance. Once we have created the thin clone, we can decouple this thin clone by selecting this option. So here we get a message that explains what the thin clone decoupling does, and the message asks us whether we would like to continue. So if we select to decouple thin clone to continue, the decoupling process is initialized, and the time of the decoupling depends on the data volume. Once decoupling is almost complete, we get another message which is asking us whether we would like to finalize the decoupling process, which actually would mean that we would like to, asking us whether we would like to start this instance as a standalone data link instance. So once we finish decoupling, the decoupled instance is being started. And once it starts, it just runs like any regular data lake relational engine instance. So this has been our Q2 news from the data lake relational engine, and I will be handing over to Shabana.
Did come out with an announcement of rolling out our database object discovery tool and data retrieval tool at TechEd, and now they are all ready to be rolled out in July version of 2026. And I know I already covered this as part of the last webinar, but again, I just wanted to bring it back to the notice. Just take an example of a persona and bring out the value that these capabilities convey to our users, right? So I'm taking Samantha in picture here, who is a business analyst. So Samantha wants to understand her business data and she wants to answer her questions much more quickly, but she doesn't necessarily know which tables or like what exists in her database, how they're connected, or how to write any complex SQL queries, right? And this is exactly where the HANA Cloud database object discovery tool and the data retrieval tool would come into picture. And the discovery tool would first help Samantha to understand the data landscape. So it automatically exposes database objects, metadata, and any other relationships through the custom database object knowledge graph that we have beneath it, and thus by allowing her to discover any relevant data without having to go through any manual browsing of the schemas or going through hundreds of tables, right? And once the relevant objects are identified, that's exactly where the data retrieval tool takes over. And now the persona can simply describe what she wants in natural language, and the agent should be able to translate that intent into an executable database query. And together, these tools are basically converting a traditionally technical process into a conversational experience, which is allowing the users to move from business question to an answer that is available much more faster. So the result is like you have a less manual modeling and integration effort. There is automatic understanding of your database context, and there is this easy access to HANA-based capabilities through, so these tools can be easily consumed via your custom agents and also through your own open standards, such as the MCP layers that could be on your site. So that was a quick update on those two tools that we are rolling out. And now moving on to the knowledge graph engine updates. What is new? So we are now announcing the support for federation through the Sparkle service in the knowledge graph engine. One of the common challenges our users have had is that the knowledge and the semantic data, they have been often distributed across multiple landscapes or systems or business units. Even they could be staying in different HANA Cloud tenants. So with the Sparkle Federation aspect, the HANA Cloud would now allow users to query multiple knowledge graph engine instances using a single Sparkle query. So the important point is that the data stays where it is. There is no need to extract, replicate, or consolidate data into like a central repository before you running any analytics or semantic queries. And behind the scenes, the Sparkle service capability is automatically routing the subqueries to appropriate knowledge graph endpoints. It is retrieving the results, and it is then combining them into a single response. And for end users, this means that they can work with the unified view of the knowledge across their organizational boundaries, while also continuing to leverage the existing data landscapes that they have. And this is definitely going to help with eliminating data silos. It will reduce the data movement a lot, and it will also simplify the integration through standards based on Sparkle. And it's definitely going to enable some richer AI and RAG and semantic reasoning applications that can now access the knowledge graphs wherever they reside. So now looking at how the federation works behind the scenes. So when a federated Sparkle query is submitted, the HANA Cloud would first validate that all configured knowledge graph endpoints are available and reachable. And it then establishes a secure authenticated connection to each of the remote endpoint using the SSL and TLS certificates. And next, the federation engine would analyze the query and determine which portion needs to be executed on which remote knowledge graph. And this is rather than moving your data around, it is pushing the relevant subqueries directly into the source system. And each endpoint then executes its portion of query, and it then the results, right? So how does it look like? From an example standpoint, as you could see, we have a basic federation example that I have there. So here we are trying to find companies whose revenue is greater than 1 million. So instead of copying the entire finance data into the local system, the HANA system here is sending the query to the remote finance endpoint, and it is going to get the results back, and then the processing continues from there. And we can also do cross-instance join. For example, like we have two domains here in the bottom query that I have. We have the payroll knowledge graph and the HR knowledge graph. The query is here combining information from both places, right, through a single query. And that's exactly the value add as well. And now I would like to just move on to the next one, which is, again, a very interesting topic where we are introducing the support for conversion from knowledge graph to property graph. So one of the strengths of HANA Cloud is that it supports both property graph and knowledge graph area, right? And until now, customers have been able to convert their property graph into knowledge graph since Q3 of last year. And with this release, we are completing that journey. because we are introducing the reverse conversion as well. So we are rolling out a new built-in procedure. So now the customers can convert an RDF named graph into a property graph workspace. And many customers basically model their data as knowledge graphs because they want rich semantics and standard-based RDF model in their use case. But sometimes they also want to leverage property graph capabilities such as, graph traversals, shortest path analysis, network analytics, and graph visualization aspects. So I think with this conversion capability, they can exactly do both of the things without having to rebuild their data model somewhere else, without having to create any duplicate copies of the data. So we are providing this true bidirectional interoperability between knowledge graph and the property graph model. So this is going to give our customers a lot of flexibility to choose the best graph engine that would work for their workload. And then just looking at how the conversion of knowledge graph to property graph works. So we start out with RDF named graph where the information is represented as triples. And for example, if I move on to the screen, so as you could see on the example here, so Alice here is represented as an employee. She has a salary value and she belongs to engineering department, and it's all through triples. And when we do the conversion, we are defining how these RDF concepts would map to a property graph model, such as like RDF class, like for example, employee, it would become an vertex table. Subject URIs would become vertex identifiers, and relationships such as you see on the screen, departments, membership, they become graph edges. And some of the literal values such as salary, they could become vertex properties. So once all of these mappings are defined, a conversion procedure would read the knowledge graph and automatically generate the corresponding property graph workspace. Maybe I could quickly explain it through a demo as I wanted to. So first I would start out with an example knowledge graph. This is a supply chain knowledge graph where we have some supplier data as well as product data. So I'll be just creating this knowledge graph at first. So once we have the knowledge graph in place, we can also query this knowledge graph to just get an understanding of what stays in there. So as you could see, we have the suppliers, the country they belong, the risk level, and the lead time delays as we inserted in our own knowledge graph. And now comes the interesting part where we want to do the conversion, right? So first we would be creating a target vertex table. We'll be creating an edge table. Then we do the mapping table that would read from our knowledge graph and store in the mapping table. And that is when the next step where we create the knowledge graph and use our inbuilt procedure. So let's see how that works. So first and foremost, let me create the schema. And now next I would be creating a column table, which is my notes table here. As you could see, I'm specifying the node ID, node type, the country, risk level, and the lead time details of the supplier, who would be my nodes. And next is the product one, where I am now going to create an edges table, which would define the relationship between the suppliers and products. And next, I'm going to be creating a column table, which is my mapping table, which would hold the workspace schema name, the workspace table name, the field names that need to be mapped properly. And now next, I'm going to be populating that mapping table. I'm going to read the exact URIs from my knowledge graph that would be populated back into my nodes table first. So you could see which URIs would map to which columns as I have defined. And next for my edges table, I do the same thing. I map my URIs back to my edges table columns. And once that is all done, I'm going to be creating an empty empty property graph workspace to which my knowledge graph should be mapped. And if I look at my knowledge graph, my property graph now, it should be empty, as you could see, because I haven't done any mapping. And now I will be running the mapping built-in procedure, which is RDF graph to knowledge graph workspace. So I'm going to specify the schema name, the graph workspace name, and the knowledge graph from which my graph workspace should be populated. And also the mapping mode and the map out parameters are also mentioned. So once I do the mapping, As I could see, the mapping is now successful, and I should be able to take a look into my nodes of my property graph, which is now populated. So we have the nodes, the type of the node, the name, the country, everything defined, and they are all available now as a graph workspace. And with that, I would like to hand it over to Christoph. Thank you, everyone.
Thank you very much, Shabana. So I'd like to give you now an overview of the new innovations in the area of our database, ML and AI engines, as well as kind of a key set of new integrations with AI Core for different purposes. So very interesting. But let's start with the innovations for the database AI engine functions within the predictive analysis library. So there's a new function for tabular data generation with a state-of-the-art algorithm called the diffusion function. So basically what this algorithm does, it learns kind of the distribution of the data and continuously adds noise to the model, understanding the data until the data looks like completely random within the model, and then takes away that noise again to be able to kind of come back to the original data. This is called a diffusion process. And with that, one is able to generate synthetic data, which mimics your real data, where you may want for data scientists training machine learning models during the development time to ensure data privacy of the data, or you may need additional data, larger amounts of data for training a good model. In the area of time series analysis and forecasting, we're adding a couple of new capabilities like outlier detection on a voting-based approach using different outlier metrics, now supported in AutoML for time series. The unified function for time series supports cross-validation, for example, better helping to immediately evaluate how good a forecasting model is and looks like. And then a feature which we implemented on behalf of customer requests using the additive model time series analysis algorithm, as known as Profit in other implementation, where we now support a feature called lagged regressors, which on the right-hand side is indicated by the graphics where time series of covariates are correlated to the target time series. So if you look at Y being the blue value time series and the temperature has a similar pattern, but in a different, let's say, time lag, and therefore the values are correlated, and such covariates can now automatically be identified and used in time series models. Then in our unified classification procedures, we better support multitask prediction. So if one model shall predict multiple target values, so for example, an order class and an order value, for example, this is now better supported in the prediction function for unified classification. Also for larger data sets, our univariate analysis procedure has been enhanced for step-by-step analysis to get an overview of data sets and the column value distributions in order to kind of handle larger amounts of data step by step. And our text preprocessing functions for text tokenization now allow us to specify separator tokens. For example, if one wants to tokenize input text but keep a certain pattern, for example, a pattern of an email address where we may need a dot and where we may need the sign, then the character, then we can specify such a pattern using the text tokenization function and keep the pattern as part of the tokenized result set. Certainly, our Python machine learning client adds capabilities from the last release and additional new functions in the current release 2.29, along with the versioning number of the general HANA client. And now let's look at the AI Core integration capabilities. In the Q3 release of 2025, we have added support for remote source definitions, where we can reach out to AI Core for embedding models, text embedding models. So as given here on the right-hand side, our vector embedding function can make use of remote, hosted on AI Core, or interfaced via AI Core general purpose text embedding models. We have extended this capability now also to support tabular foundation models, so RPT1 specifically, or general large language models for different scenarios, which we'll come to in a second, and also look at the functions leveraging those remote sources. Certainly, as also indicated here, this remote source capability enriches our in-database models as part of the NLP services in HANA Cloud, where we host local text embedding and local cross-encoder and other text analysis models. So let's look at the predictions using RPT1. RPT1 is SAP's tabular foundation model, which allows to generate on-the-fly predictions using this general foundation model, where we only need to provide context to the actual prediction. We don't need to train a machine learning model, manage the lifecycle of a machine learning model. We can simply call out to this RPT1 and then receive and manage and work with the predicted values. Pretty nice. And we'll see that in a second in a demo. And the second function is kind of a starting point to our general large language model integration from HANA Cloud using a SQL functions for AI text completion. So we can basically specify a kind of a single shot prompt scenario where we provide some data as JSON out to the function with our prompt description and can receive back the results, and with that can create a whole new type of applications where we can leverage LLM responses as part of our database applications. And with that, let's take a look at a couple of demos briefly. So the first thing what you would need to do certainly is create these remote sources of type generative AI hub. In my example, as you can see here, I've already created 3 remote sources. We use certificate-based authentication between HANA Cloud and the AI Core instance, therefore that needs to be managed. So let's look at the prediction use case with AI Core. So as mentioned, I've created a remote source of type GenAI Hub. And what I'd like to predict now in my scenario, I have financial transaction data of various kind, and I have a fraud column, and that's basically what I wanted to do. I have 500,000 rows here in my data set. 10,000 of them are fraudulent. And what we can now do, call the new functions AI tabular prediction, where we refer to the remote source. And as input, we provide context and prediction data. The context is basically a subset of data which is similar to what we want to predict. The RPT1 model is a tabular foundation model. Certainly it has no indication of what our data looks like. So therefore the columns, the order, the names of the columns, etc., and the content of the columns help the RPT1 model to understand the context of our data. And then with the predict set, we basically pass over the data where we want to generate the predictions. Therefore, in the context column, in the context set, we have the target column fraud, and for the predict set, we don't have that. And as part of the configuration, basically we define we want to do a classification task and predict values for fraud. It could also be multiple columns, also a mixture of classification and regression. And by running this function, we're sending over 128 rows for prediction. We basically consume back the results. So pretty straightforward and no management of local machine learning models are required anymore. The second scenario is about integration with AI Core. And again, we have remote sources, and we have remote sources of AI Core. And in the second query, I'm querying for those AI Core models which support the embedding task. And I'm doing this because what we want to do is basically analyze complaints of the National Highway Traffic Safety Administration government organization in the USA, where customers describe problems they are observing with cars in the US. And as a first step, I'm filtering down on a given model and make, just to reduce the amount of data we are processing. And what I'm doing, as you can see here, the vector embedding functions uses the column CD description, which is the complaint description, and passes this over to the AI core instances, and it's run through the text embedding model ADA 002.2. And we're receiving back the result, which includes here the vector column. As a next step, we may want to kind of search for a specific pattern in that data. Maybe any of the complaints where people expressed concerns where the touch screen has a problem and something is freezing. And what we do here in two steps. First, we again use the vector embedding functions to process the query or generate the embedding for our inquiry, the touchscreen problem. We then get back a list of results that including the vector similarity search, so something classic we have been doing for a while now. And in the second step, we reorder the result set using the cross encode functions in HANA Screen to get a more accurate retrieval set, as the cross encoder model which we provide as out of HANA Cloud helps us for a more accurate similarity score. And we see that here in the second result set, that the actual kind of top one item as of the text better matches the problem we have been searching for, and therefore that's a better result set. Secondly, what else can we do in HANA Cloud? We have machine learning algorithms which we can apply to our vector data. And as we have now vector data for our problem in focus, cars which had problems with the touch screen being frozen, we can also run a clustering algorithm here. And basically that identified, in this case, 3 clusters. And what we want to do now, lastly, basically using the AI core integration, and we've done these previous steps just to kind of come to the point what we want to do. What we want to do is for each of the identified clusters to have the LLM to create a summary generation for what is the typical problem defined or identified in these clusters, or what these clusters do represent. And this takes a bit, but then here we are, and we basically can consume back the result by these new functions and get a nice cluster description generated by the LLM, which we have been using here. And as you can see here, we have been using the new functions, AI text completion, where we specified the LLM we wanted to use, and also again specified certainly the AI core instances we wanted to use. And with that, I'd like to close this section and hand over to the next speaker.
Yeah, for the last minutes of the session, I'm happy to give a little bit of an update what's happening in the area of multi-region disaster recovery. My name is Ralf Zekala. As the other speakers, I'm part of the product management looking out for the business continuity topics you can imagine in HANA Cloud. That said, let's go and present what we did over the last weeks and months. We showed already we are investing in multi-region or long distance disaster recovery. It allows and gives our customers the capability and empowers them to initiate failover on their own, or they can wait for SAP to declare a disaster, and then we from SAP are triggering this process. At the end, it's an asynchronous replication. On the right side, you see the 3 options we have in combination with long distance replicas. It's a simple DR kind of replication. It's a combination of HA and DR and a combination of multi-zone HA and multi-region DR in one setup. And of course, the last one is the most secure one from our perspective. We started with AWS. This is well established. We have the first customers productive running on that. We are about to release, and you will see the graphical designs shortly after, the geographically presented slides for that. So we are now finishing the Azure offering between North America and Europe, on North America and on Europe. The focus is always and is still to stay in the same jurisdiction with the same service provider, as you can see here in this slide. We had some surprises, and this is the reason why Azure is now a little bit late here in this picture. You will see we plan now in round about a week to release it finally end of June. And with that, we have then a good offering already with 2 partners here. What's about interfaces here right now? We are still forced to use the API, which is offered from the central DR server, which is part of the BTP overarching design. And this central DR server colleagues now announced that QRC3, they would like to bring a graphical tool for that. So long you can simply use the API. It's a little bit more complicated, well described here in our documentation. So please have a look. With that, I think, and I'm really certain that you can finish that. There are still some restrictions here, but we are working heavily on that to release them, and we will, as usual, announce this with the Roadmap Explorer. So here shortly the different regions. You see AWS in orange, in pink you see Azure, and with this also this node here, we now plan to release the Virginia, Washington, US 20, US 21 end of the month. Similar in Europe, EU 20 in Amsterdam to EU 22 in Frankfurt is planned for that, and the 2 others in AWS are already released for quite some time. What's also new now is our next step, which is now coming, and hopefully, and so far we didn't get these surprises we had before in Azure. So GCP is looking good, very good, to be frank, and now we are extending our offering to that partner. We are starting in Japan, coupling Osaka and Tokyo. Actually, customers in Japan were the first ones years before to ask for this kind of long-distance disaster recovery. And of course, we can understand with all the disasters they often have with tsunamis that they ask for these kind of possibilities. More regions to come. We are preparing that, and we are still excluding the data lake files support, and the setup is still to be done with the API. And to give an early view and what we are planning for the rest of the year, one of many is India. India is also a very important market for us, and here we have already today this data center in Mumbai, EN30, and end of this year, beginning of next year, we plan to have also a second one in Delhi, so that we at the end can offer long distance replication in between. So the plan is somewhere early Q1 2027. It's still a little bit time out. You know, we are working here together with an external partner, which is always, giving some surprises, you could name it, but I hope at the end this all will nicely work out, and end of the year we can talk more concrete about what is to be expected. With that, thanks for your attention, and I would like to hand back to Andrea.
Thank you, Ralph. So with that, let me just share the last further contents that we have just shortly. Don't forget to check our What's New in SAP HANA Cloud blog post that we will be sharing, and as well as our teaser trailer if you want to check some short pics around their innovations from Thomas Hammer. And additionally, I want to remind you that the HANA TechCon is happening on the 16th of July. So please register in this QR and get your tickets, as we are running out of tickets already. And you will for sure want to participate. This event is happening in St. Leon Road. And you will be able to network with SAP developers, users, and partners from everywhere. So thank you very much to all our speakers, and have a good rest of your day.